Okay, here we're doing the solutions to factorising and solving quadratics. So starting off with this one, we're going to make two single brackets. So I'm going to take a 2 out of these first two terms, and I get x plus 3. And then out of these two, I can take minus 3y, and then inside those brackets, hopefully we're going to get the same thing. Yeah, we do. And then I've got 2 times x plus 3, and I've got minus 3y times x plus 3. The way we can write that is 2 times x plus 3 minus 3y times x plus 3. So we get this double bracket here, because if you think about how you expand it, first outsides, that's your 2 times by both of those, and insides and last, that's your minus 3y times both of those. Okay? We're going to be using that technique a lot, so make sure you're pretty familiar and happy with how that works. Okay, so on to the next one. Again, we're going to do the same thing. Now, with this 1 plus x, it looks like we can't really factorise anything out. So what we're going to do is we're going to cheat a little bit, and we're going to take a factor of 1 out. We're going to do that when we don't really know what else to do. Inside the brackets, I'd end up with 1 plus x. With these, I'm going to take negative y out. And inside the brackets again, I end up with 1 plus x. We always want this to happen, to have this second bracket the same. If it's not, either we need a different way of factorising it, or we've made a mistake somewhere. Okay? So, here we end up with 1 minus y in the first bracket and 1 plus x in the second. It doesn't matter which way round we put the brackets. We could put 1 plus x first and 1 minus y second. It doesn't matter. For this next question, same idea. I'm going to make a single bracket with the first two. I can take 2 out, and inside the brackets I get x minus 3y. And out of these two, I can take either a or minus a. Now, if I took out a, I want to show you what's going to happen and why it's going to be a problem. So if I take out plus a, inside the brackets I'm going to get minus x and then plus 3y. And at this point you should notice that these two brackets are different, and like I said, that's a bit of a problem. Okay, here we've got minus x, we wanted plus x. Here we've got plus 3y, we wanted minus 3y. And that's your clue that actually we don't want to take out plus a, we want to take out minus a instead. So that's what we'll do, and that should fix the problem. And here minus a times x is minus ax, and then minus 3y, because minus a times minus 3y gives us plus 3ay. So 2 minus a and x minus 3y. This one factorises slightly differently. This is something called the difference of two squares. Okay. Now actually, before we can use the difference of two squares, we need to factorise something out of both of these things. So I'm going to take a number out of both of these. Now, to me, the only thing that I think I can divide both of these by is 3. So I'm going to take a 3 out in front. And that leaves me with 16x squared minus 25y squared. And here, this is where I was talking about the difference of two squares. This is a square number, and this is a square number. And the difference of two squares factorises like this. I'm going to do the square root of this. That's 4x. And then the square root of this. And for one of the brackets, that's going to be plus. And for the other bracket, it's going to be minus 5y. Now the reason that works is if I were to expand this here, the firsts I get 16x squared, the outsides I get minus 20xy, the insides I get plus 20xy, and the lasts I get minus 25y squared. And because of this minus 20xy is minus and this 20xy is plus, they cancel out, so we're just left with those two terms. Okay, so this only works when you've got square numbers and when it's subtract. That's why it's called the difference of two squares. Okay, so I'll just get rid of all of that extra stuff, and I just want 3 brackets 4x plus 5y 4x minus 5y. By the way, it's better to keep that 3 outside because that's fully factorised. If you were to multiply that 3 with those, then it's not factorised completely. You've expanded part of it. So it would be wrong to multiply by 3. This is also the difference of two squares. This is 3y all squared. So in our first bracket, I'm going to write 3y plus 4. The square root of 16 is 4. And in the other bracket, 3y minus 4. To be honest, it's almost a bit more confusing, the fact they've written 3y squared. If it helps, you can just think of that as 9y squared, which is what that is. Okay, and 3y times 3y gives me 9y squared. This next one here is more like the first few we did. So what we're going to try and do is factorise this first one. What can I take out of both of these? It doesn't look like I can take out much out of these. So what I'm going to do is I'm maybe going to try and rearrange it a little bit. Okay. So I'm going to write 15ab and put either minus 3a or plus 5b next, because when I'm looking at those I feel like I could only take one out. Okay, and I know I did that above, but I'll just show you what would happen if I actually tried to do that. I get 1 brackets 15ab minus 1, and then here there's nothing I can factorise out of these either. Again, it'd be like minus 1 brackets 3a minus 5b, and those two brackets aren't the same, so that hasn't worked. So that's why with this one I'm just going to rearrange a little bit. So I'm going to put the minus 3a next, and then let's put the plus 5b and let's put the minus 1 last and see if that works at all. Okay, so now there is something I can factorise. I can take 3a out of both of these, and here I want 5b minus 1, and this one I am going to take 1 out, but this time it's going to work. When I take 1 out, I get 5b minus 1, and look, I do get that same bracket this time. So it's 3a plus 1 5b minus 1. You might be thinking, well, how did you know to put that minus 1 at the end? To be honest, it's because I could already see this pattern developing. But if you put it in the wrong place, it wouldn't really matter. Okay, if I'd have put the minus 3a here and then minus 1 and then plus 5b, the first thing would have factorised just the same. And then you'd have factorised maybe 1 out, and then you'd have spotted, hopefully, that you get minus 1 plus 5b, and all you need to do is switch those two things around and you get the same thing. It would have worked just as well if we'd have put the 5b next as well. If you can try that if you want, and you'll see you'll get exactly the same factorisation, the same answer. Bit of a tricky one, that one. 3a plus 1, 5b minus 1. In this question, we've got a quadratic, but with a factor of x squared. Now what we're going to do in these cases is we're going to write ABC above each of the coefficients. A has to be the one in front of x squared, B the one in front of x, and then C the final one. And I'm going to use something called the AC method. So what I'm first going to do is I'm going to multiply A with C. So 6 times minus 3, that gives me minus 18. Now I'm looking for two numbers that multiply to give minus 18 and add to give minus 7. Because minus 18 is negative, that means one is going to be positive, one is going to be negative. So that means that because one is negative, I'm going to end up subtracting one from the other. So I'm looking for numbers with a difference of 7. Okay, so my factors are 1 and 18. They have a difference of 17, so it's not them. 2 and 9 would be next, and they do have a difference of 7. So those are the numbers I'm going to want. One's got to be positive, one's got to be negative. I'm trying to get minus 7, so that means I want plus 2 and minus 9. Otherwise, if it was the other way round, I would get plus 9 minus 2 gives me plus 7. Now what I'm going to do with these two numbers is I'm going to rewrite this quadratic, but instead of the minus 7x here in the middle, I'm going to write plus 2x minus 9x, and then the minus 3. So look, all we've done is we've split the middle, because that thing there is just exactly the same as minus 7x. So I found those two numbers just to be able to split that middle term into those two things. And now what I'm going to do is I'm going to do single brackets like I have done in previous questions. So out of these two, I can take 2x, I get brackets 3x plus 1, and out of these two, I'm going to take minus 3, and in the brackets 3x plus 1. So in the first bracket, 2x minus 3, 3x plus 1. It's a really important technique to know that the AC method. I'm sure some of you have other methods, like you might do it by inspection. This is a nice method that works in any case, really. So it's a worthwhile one to learn and to be able to use, so you don't always have to rely on inspection. Inspection becomes difficult when there are numbers like 24 here, which has lots and lots of factors. They can be more difficult to solve by inspection. So now this next question, it looks like almost the same numbers, but it's not. I'm going to use that same technique again. We'll do it a bit quicker this time. So I'm going to do AC. 6 times minus 6 is minus 36. So I'm looking for two numbers that multiply to give that. And again, one's positive, one's negative. So I want the difference between them to be 5. The factors of 36 are 1 and 36, 2 and 18, not close yet, 3 and 12, 4 and 9. Those are the ones with the difference of 5. So those are the ones that I want. And it's going to be plus 4 minus 9 to give me minus 5. Now let's split the middle. By the way, it doesn't really matter which order I put these two numbers in, okay? Normally we'll try and put it so that this one shares more factors in common with the first one. That's the one we'd put second. That just avoids us sometimes having to take a 1 out in the second bracket. But it doesn't really matter. I could have put the plus 4x next and the minus 9x second. It wouldn't have really mattered. Right, out of these two, I can take 3x and I get 2x minus 3. And here I can take plus 2 out of these, and then 2x minus 3. So we get 3x plus 2, 2x minus 3. This time we've got one more step though, because we're solving an equation. Because it's equal to 0 and I've got my two factors here, this means I've got either 3x plus 2 equals 0, that's the first factor, or 2x minus 3 equals 0. Subtract 2 from both sides for this one, 3x is minus 2, and divide by 3, x is minus 2/3. For this one, add 3 to both sides, 2x is 3, and then divide by 2, x equals 3 over 2. Minus 2/3, or 3 over 2. This next question is just a factorising one, so I think it's going to be two single brackets. So first I'm going to look for what I can factorise out of the first two terms. It looks like I can take a 2 and an x, and then in the brackets cx minus d. And then for this one here, if you look carefully you should spot that, well, the only thing I can take out is a 1, but ideally I want to take out a negative 1, because when I take out a negative 1 I'm going to get plus cx inside the brackets and then minus d as well. Minus 1 times minus d gives me that plus d there. So we get 2x minus 1, cx minus d. Similar idea for this one. Sometimes it's just worth checking if we need to do a little bit of rearranging. I don't think we need to for this one. Let's try it without. So let's see what I can factorise out of both of these. Doesn't look like much, so I'm going to take a 1 out. 1 brackets 1 minus q. And for these, I'm going to take minus a out. Minus a brackets 1 minus q. So in the first bracket, 1 minus a. And in the second bracket, 1 minus q. You could have rearranged that and it probably would have worked just as well, but as long as you can spot that you can take a 1 out and you end up with the same bracket both times, it works fine the way it is. Okay, this looks like one that I might need to rearrange, because if I took 1 out this time, I'm just going to get mt minus n, and if I take 1 out of this one, or even minus 1 out, I'm going to get m minus nt, and those brackets aren't the same, and it's not just a negative which is stopping them from being the same. So this is one where I'm going to do a little bit of rearranging to try and put things with the same letters together. So mt, this one's got an m, so I'm going to try putting that there instead, and then maybe putting nt next. Look, because that's got a t, so I'm going to put that one first and then put the minus n at the end. So out of this one I can take an m and then t minus 1, and here let's take plus n out, and again I get t minus 1. That's why I put the one with t in front. Again, if you'd have done it the other way around, that would have been fine. You'd have got minus 1 plus t and just realised that you needed to switch them over. So in the first brackets, m plus n, and in the other brackets, t minus 1. This question, once again, looks like one that I could do 2 single brackets with, but not currently as it is. Because I'd only be taking a 1 out of the first 2, and that wouldn't give me the same in the second bracket, so I'm going to do a bit of rearranging. So I'm going to put one with an m in maybe next to this one, so I'm going to put the minus 8km next, and then I'm going to put plus 3p minus 12kp, and again I put this one second because this one has a k. So that's going to go in the second bracket. In the first bracket is the second term, and again this one's going to be the second term in that second bracket, so that's why I'm putting it last there. Now I'm going to take 2m out of the first terms and I get 1 minus 4k, and here we can take 3p out and I get 1 minus 4k again. So our 2 brackets are 2m plus 3p, 1 minus 4k. Okay, this looks like we've got squared things, we've got a minus sign, so it looks like the difference of 2 squares. The problem is that 5 and 20 are not square numbers. So what we need to do is first we're going to take 5 out. When I do that, I get x squared minus 4y squared. Now I do have 2 square numbers. So it's the difference of 2 squares. I'm going to do x plus 2y brackets x minus 2y. It would be okay to keep those big square brackets, but they're not really necessary. I'll put them there just to help show that we're taking a 5 out first out of those square brackets. After having done that one, you should be able to have a go at this one. Okay, so same kind of idea. It looks like a difference of 2 squares, but it needs to be factorised first. Again, I think we're going to take a 5 out. In the brackets, 4x squared minus 9y squared So brackets 2x plus 3y, 2x minus 3y. This one here, we've got a more standard quadratic. We're going to need the AC method, so let's write down ABC. AC is equal to minus 10. 2 times minus 5 is minus 10. One's going to be positive, one's going to be negative. We want them to have a difference of 3. The factors are 1 and 10, 2 and 5. Those are the two with a difference of 3. I want minus 3, so I want plus 2 minus 5. Now let's split the middle. 2x squared plus 2x minus 5x minus 5. And make two single brackets. 2x brackets x plus 1 minus 5 brackets x plus 1. So we get 2x minus 5 x plus 1. This next one here, not as obvious to spot, but here we've got 9x squared, that's a square number. 1 is also a square number, so it's the difference of two squares. So in the first bracket, 3x plus 1, in the second bracket, 3x minus 1. Here again, we've got one of these questions where it looks like two single brackets, but it might need a bit of rearranging first. I could take 2 out of both of these, but I'm going to end up with an AX and a BY. It's not going to give me the same sort of bracket as this. So what I'm going to do is first do a bit of rearranging. 12AX, and I'm going to put the plus 3AY. I think it would also work if I wrote the minus 8BX as well, by the way. Next I'm going to write minus 2BY minus 8BX. And this time you're going to see that I've actually ended up putting these the wrong way around. I'll show you what that means in a second. Okay, out of both of these I can take 3a and I get 4x plus y in this bracket. Out of both of these I'm going to take minus 2b and I get y plus 4x minus 2b times 4x gives me minus 8bx. Okay, so then you'll notice, look here, I get 4x plus y in this bracket, and in this one I get y plus 4x. That's just because I put those two the wrong way around. It doesn't matter. Those two things are exactly identical, so I can just rewrite it. The second bracket is 4x plus y, it's the same thing. So in my first bracket I get 3a minus 2b, and in the second bracket 4x plus y. This one here again, it's an AC method. So AC, 5 times minus 8, minus 40. So one is positive, one is negative, and we're looking for numbers with a difference of 6. So it's not 1 and 40, it's not 2 and 20, 3 doesn't go in, 4 and 10, well it's going to be 4 and 10 because they've got a difference of 6. And I want minus 6, so that means I want plus 4 minus 10. So now I'm going to start rewriting the quadratic. And this is an example where it's going to make it a bit easier if I put minus 10x first and then plus 4x. Reason I do that is 10 has more factors in common with 5 and 4 has more factors in common with 8. It would work fine the other way around, but you'd find yourself having to take a 1 out as a factor for the second bracket. So here 5x brackets x minus 2 plus 4 brackets x minus 2. So we get 5x plus 4 x minus 2. Next one here, this is a straightforward difference of two squares question, a squared minus b squared, so this is a plus b, a minus b. And now this question here, it's really important to notice that this is part B following on from this. They do not expect you to do 5.37 squared and subtract 4.63 squared. This is likely to be on a non-calculator paper, right? What they want you to spot is how similar this is to what is above. So all I'm going to do is I'm going to factorise this exactly like I did above, but A is 5.37, so I'm going to write 5.37 plus B. B is 4.63. So that's like the first bracket, A plus B. Now I want the second bracket, A minus B. 5.37 subtract 4.63. Now these things actually work out quite nicely. That's the whole point of this question. When you add these two things up, well, 0.37 add 0.63 is 1. So 5.37 add 4.63, that first bracket there just gives me 10. And this bracket here, this one looks a little bit more difficult, so I'm just going to work out the difference to get from 4.63 to 5. What's that? 0.37, and then we want another 0.37. So 2 times 0.37 is 0.74. Okay, you could also do that using a bit of written methods. And then look, we've just ended up with 10 times 0.74, which is 7.4. That's why that's only 2 marks. They don't expect you to evaluate all of that and do something more complicated. Okay, this next question here is another 2 single brackets. I think I can just take a 1 out of the first one and get 1 plus A. And here let's take minus C out of the second one, and again 1 plus A. So our first bracket is 1 minus C. Our second bracket 1 plus A. And we've got an AC method again, so let's write down A, B, C. And AC is 4 times minus 6, so that's minus 24. One's positive, one's negative. We want them to have a difference of 5. It's not 1 and 24. It's not 2 and 12. It is 3 and 8. We want minus 5, so we want it to be plus 3 and minus 8. Now let's split the middle. 4x squared. Which one do you think should go next? Minus 8x or plus 3x? Hopefully you guessed right. It's minus 8x. So 2 single brackets, 4x brackets x minus 2 plus 3 brackets x minus 2. So 4x plus 3, x minus 2. And don't forget, we actually want to solve it this time. So we've got 4x plus 3 equals 0, or x minus 2 equals 0. So 4x equals minus 3. So x is minus 3/4, or x equals 2. This one here, we've got 2 square numbers. So it's the difference of 2 squares. Square root of 49 is 7. Square root of 16u squared is 4u. So we've got 7 plus 4u, 7 minus 4u. For that first one there. When you get the hang of these difference of 2 squares, they're not too tricky. This one here looks like 2 single brackets. If I took 1 out of this first one, I'd get 1 plus 4xy. I'm not going to get the same thing if I do the same with the second one. So what I'm going to do, it's one where I'm going to do a bit of rearranging first. So I'm maybe going to do 1 minus 2x, and then minus 2y plus 4xy. Again, you could have tried a slightly different order and you could still end up with the same thing. I'm still going to take a 1 out of this first one. 1 brackets 1 minus 2x. And here I'm going to take minus 2y out. And I get 1 minus 2x again. Minus 2y times minus 2x is plus 4xy. So we end up with 1 minus 2y 1 minus 2x. This one looks like a similar idea. Now this one here, it does look like I can factorise this as a single bracket and this as a single bracket, so let's just try that straight away. Let's try taking 3 out of the first one, 3 brackets x plus 2, and then minus 2y times x plus 2. Yeah, that's worked quite nicely. So brackets 3 minus 2y, brackets x plus 2. Again, this looks like one I think I can just start factorising straight off. Let's see if it works out. For this first one, I can take 3a out of both the first terms, and in the brackets 2x plus 3y. And then out of these two, let's take minus 4b, and then we get 2x again, and we get plus 3y again. So yeah, that's worked out quite nicely again. It's brackets 3a minus 4b, close brackets, and then brackets 2x plus 3y. Okay, this is much more straightforward quadratic. There's no coefficient, so in this one, there's no coefficient of x squared, sorry. So I can already do my 2 brackets with x there, and I'm looking for 2 numbers that multiply to give minus 6 and add to give minus 1. So it's numbers with a difference of 1. So the factors of 6 are 1 and 6, 2 and 3. They have a difference of 1. I want minus 1, so I want it to be plus 2 and minus 3. So x plus 2, x minus 3. Okay, this one here. Again, I think this is one I can start factorising straight off because I can take x out of both of these already. So let's try that. Let's take x out, and in the brackets we get 3a plus 2b. And here let's take minus 2y. And when I take that out, I get 2b plus 3a. And you'll notice these are actually the other way around. Doesn't matter, I can switch those around, no problem. Okay. 3a plus 2b is the same as 2b plus 3a, so that's absolutely fine. So we get x minus 2y in one of the brackets and 3a plus 2b in the other, or 2b plus 3a, doesn't matter which way around you write that. Difference of 2 squares here, we've got h squared, which is a square number, so h, and 144 is a square number, the square root is 12, so h plus 12, h minus 12. The next one, let's just try taking 1 out of the first bracket, so 1 brackets 1 plus x minus y, brackets 1 plus x, so 1 minus y, 1 plus x. We should be starting to get used to these type by now. This one here, it looks like it could be something to do with the difference of 2 squares, but maybe I need to do a bit of factorising first. So I can take 2x out of both of them. So let's do that, 2x, and then I get x squared, and I get minus 9y squared. Now let's not leave it there, because these are square numbers, so it is the difference of 2 squares. So x plus 3y, x minus 3y. So 2x out in front, and then the difference of 2 squares, x plus 3y, x minus 3y. Okay, so here we've got an equation which I guess is going to lead us to a quadratic. So first of all, let's rewrite this and give ourselves a little bit more space. Okay, now to be able to like combine these two fractions into one, I need to make the denominators the same. So I need to multiply top and bottom of this one by 2x minus 5. And top and bottom of this one by x plus 1. So on the bottom of my fraction, I'm going to get x plus 1, 2x minus 5. Let's keep it factorised for now. On the top, 4 brackets 2x minus 5 plus 2 brackets x plus 1. Don't forget the other side of the equation equals 3. Now what I'm going to do is I'm going to multiply up by the bottom of the fraction. Now some of you may do this in just one step, so you may multiply straight away by x plus 1, 2x minus 5 on this side as well, and that's fine, okay? I prefer to do it in 2 steps just to make it a bit clearer where this is coming from. So on my left hand side, I'm not going to get that denominator anymore. I'm just going to get 4 brackets 2x minus 5, 2 brackets x plus 1 equals 3, and then that whole quadratic from the bottom, x plus 1, 2x minus 5. Now I'm going to start expanding everything and solving it. So here, 4 times 2x, we get 8x minus 20 plus 2x plus 2. And I'm going to keep that 3 there and just expand the quadratic first. So firsts, outsides, insides, lasts. So x times 2x is 2x squared. Outsides minus 5x. Insides plus 2x. And lasts minus 5. Okay, so let's simplify the left hand side. 8x plus 2x is 10x. Minus 20 plus 2 is minus 18. And before multiplying by 3, I'm going to simplify those two middle terms. I get 2x squared. Minus 5x plus 2x is minus 3x. And then minus 5. Now let's multiply. 6x squared minus 6x, minus 9x minus 15. Now we've got a quadratic, so let's get it all onto the right hand side. So 0 equals 6x squared. So I'm going to subtract 10x from both sides. I get minus 19x. And I'm going to add 18. Minus 15 add 18 is plus 3. So now I've got my quadratic, which let's hope it factorises. I'm going to write ABC. So AC is equal to 6 times 3, that's 18. Positive 18. But this time the middle number is minus 19. So that means that both of them are going to be negative. When I multiply a negative with a negative, I get a positive, positive 18. But when I add two negatives together, I get a negative. So that could be minus 19. I'm going to start thinking about our factors of 18 then. And the first ones we come across are 1 and 18. Now 1 and 18, if I add them up, I get 19. So those are the two ones I want, except I want them both to be negative. Minus 1 subtract 18 is minus 19. So now let's split the middle. 6x squared minus 18x minus 1x plus 3. Two single brackets, 6x brackets x minus 3 minus 1 brackets x minus 3. So I get 6x minus 1, x minus 3 equals 0. Let's find a little bit of space just underneath here. So either 6x minus 1 equals 0 or x minus 3 equals 0. So 6x equals 1, so x is 1/6, or x equals 3. So quite a long question, but for 7 marks, that's not too bad, so that's doable. In this question, it has already been factorised for you. It's only 1 mark, okay? That's the clue that you do not need to expand or anything. It's done for you, okay? We have 5x minus 3 equals 0, or 2x plus 7 equals 0. So 5x equals 3. Divide both sides by 5, we get x equals 3/5. Or for this one, 2x equals minus 7. Divide both sides by 2, and we get minus 7 over 2. So 3/5 or minus 7 over 2. In this question, we're factorising. So A, B, and C. We're going to do 6 times minus 20, that's minus 120. And we're looking for 2 numbers that multiply to give 120, but whose difference is 7. Again, one positive, one negative. Now this time I'm not going to start all the way at 1 and 120, because the difference between those is 119, so that's already quite far out. So let's skip a few out and maybe go straight to 10 and 12. Well, they have a difference of 2, so it's not those 2. We could try dividing by 8, and I think 8 is 15. Yeah. 8 tens are 80, 8 fives are 40, so 8 and 15, and those 2 do have a difference of 7. So those are the 2 numbers we want. I want plus 7 this time, so that means I want plus 15 and minus 8. So now let's rewrite our quadratic, split in the middle, so 6x squared plus 15x minus 8x minus 20. Out of these 2 I can take 3x. I get brackets 2x plus 5. And out of these 2 I can take minus 4, brackets 2x plus 5. So we get 3x minus 4, 2x plus 5. For this next one here, it looks like 2 single brackets, but again I could only take a 1 out of these 2, and if I did that I'm not going to get, I don't think, the same, or maybe I will, maybe this one will work, because this one's got an x and this one's got a y, and this one's got an x and this one's got a y. So let's try straight away taking 1 out. And out of these 2 I can take 2, I can take minus 2a out, and then I get 3x plus 8y. So it did work. So 1 minus 2a, 3x plus 8y. What does this one look like to you? So to me, because of that y squared, it looks like it's the difference of 2 squares, but 27 and 3 aren't square numbers. So first we're going to take a 3 out, then I get 9y squared minus 1. Now we can do the difference of 2 squares, 3y plus 1, 3y minus 1. So 3 out in front, and 3y plus 1, 3y minus 1. Next one again looks like 2 single brackets. I'm going to try factorising it as it is, or maybe I'm not, because I can see here I can only take a 1 out of these 2, and then I'd be forced to do the same with these. It's not going to give me the same bracket, so actually I'm going to do a bit of rearranging. I'm going to get these 2 maybe with the m's together, so 2m minus pm plus 2k minus pk. Look, I've got that same kind of pattern with the p's second, the 2's first, and now let's try and factorise. So let's take m out, and we get 2 minus p, and out of these we can take k out, and we get 2 minus p again. So m plus k 2 minus p. A bit of a more straightforward quadratic here. We don't have a coefficient in front of x squared, so I can straight away put our two brackets with x, and I'm looking for two numbers that multiply to minus 28 and add to minus 3. So we've got one positive, one negative, so we want them to have a difference of 3. So it's not 1 and 28, it's not 2 and 14, 3 doesn't go in, 4 and 7, they have a difference of 3. So it's going to be 4 and 7. We want minus 3, so I want minus 7 and plus 4. So x plus 4, x minus 7. This one here is a little bit of a confusing one for a lot of people. So what I'm going to do first of all is do a single bracket, because there's something I can immediately take out of both of these. To kind of help you with this, actually, what I'm going to do is, I just want you to imagine if we had this instead, 7x squared plus 4ax. Notice what I've done. I've just replaced that a plus 2b, I've replaced it with x in both of them. If you were asked to factorise that, you probably wouldn't have any difficulty. You'd go, well, I'm going to take the x in front, and I get 7x plus 4a. And you're absolutely right. So this is exactly the same thing. I'm going to do exactly the same thing as that. So, but instead of that x, it's this kind of complicated bracket. So what I'm going to do is I'm going to take that out in front. I'm going to write a plus 2b. Yeah, that's like our x. And then I'm going to put some brackets. I'm going to write 7 brackets a plus 2b plus 4a. Look, that's exactly the same as what we did with those x's. Instead of x, I've got a plus 2b, and then 7x plus 4a. That doesn't look like it's very neat. Okay, so what we're going to do is we're going to now expand inside this big square bracket. So I'm going to leave the little a plus 2b out in front, and inside the square bracket I get 7a plus 14b plus 4a. Let's simplify the square bracket now. 7a plus 4a is 11a, and then plus 14b. And there we've got that nice and simplified, looking as neat as it can be. I can't factorise anything else out of this bracket. So the answer we're wanting is a plus 2b, 11a plus 14b. Okay, this is another AC method one. So a times c, 15 times minus 8 is minus 120. We have a positive and a negative number because we want them to multiply to minus 120 and add to minus 2. I'm not going to start at 1 and 120 and 2 and 60. It's going to take us too long to get there. These numbers are only 2 apart. So let's skip straight to 10 and 12, and actually those are the two, 10 times 12. They have a difference of 2. Okay, I want minus 2, so that means I want plus 10 minus 12. Now let's split the middle. 15x squared plus 10x minus 12x minus 8, and then make our single brackets. 5x brackets 3x plus 2 minus 4 brackets 3x plus 2. So we get 5x minus 4, 3x plus 2. This next question follows on from the one above. Look, it's exactly the same quadratic. So now we factorised it. All I want is either 5x minus 4 equals 0, or 3x plus 2 equals 0. So 5x equals 4, so that gives me x equals 4/5 when I divide both sides by 5. or here 3x equals minus 2, and then divide both sides by 3, and we get x equals minus 2/3. What does this question look like to you? To me, it still looks like the difference of two squares, but again with something that we need to factorise first. The reason it looks like the difference of two squares is because of that 16 there and because of this y squared here. So let's see what we can take out of both of them. What I can take out is an x, and then I get x squared minus 16y squared. And yet these are both square numbers, so x plus 4y, x minus 4y. If you can spot that technique, that's not a lot of work for 3 marks there in that question. This is another AC method, so let's write down ABC. For AC, 4 times minus 5 is minus 20. We're multiplying to give a negative, so that means one's positive, one's negative, and we want the numbers to have a difference of 8. Our factors of 20 are 1 and 20, 2 and 10. Those have a difference of 8. We want plus 8, so that means we want minus 2 and plus 10. Now let's use those to split the middle, so 4x squared minus 2x plus 10x minus 5 equals 0. Let's make 2 single brackets, so 2x brackets 2x minus 1 plus 5 brackets 2x minus 1. So 2x plus 5 in one of the brackets and 2x minus 1 in the other. And we want to solve it this time, so we've got either 2x plus 5 is 0 or 2x minus 1 is 0. So 2x equals minus 5, or x equals minus 5 over 2, or 2x equals 1, which gives us x equals a half. So our two solutions, minus 5 over 2 or 1/2. Here we've got another one which looks like the difference of two squares, but only once we factorise. So if I take a 2 out, inside the brackets I get x squared minus 144y squared, and then we get x plus 12y, x minus 12y. So 2 brackets x plus 12y, x minus 12y. This next one here is yet another AC method, so ABC. AC is minus 200, so we're looking for factors of 200, one's positive, one's negative, and the difference is 17. I'm not going to start all the way at 1 and 200, let's start kind of somewhere in the middle with 10 and 20. Now the difference of those is 10, so I want it to be a bit further apart than that. 9 doesn't go in. Does 8 go in? Yeah, it does. It's 8 and 25, isn't it? Because 4, yeah, so 8 and 25. And they do have a difference of 17. So those are the two numbers we want. We've got plus 17, so that means we want plus 25 and minus 8. So now let's split the middle using those. 5x squared. Let's put the 25 next. That shares more factors in common with that 5. Then minus 8x minus 40. We can take 5x out of both of these. So 5x brackets x plus 5 minus 8 brackets x plus 5. So we get 5x minus 8 in one of the brackets and x plus 5 in the other. Okay, this one is one of the trickiest questions on factorising quadratics here. So we've got three terms, so it's not the difference of two squares, nor is it two single brackets. So it's like a quadratic, this one. So it's like a quadratic, like the AC method, except this time, let me rewrite it. The coefficients are these. So A is 5, B is minus y, and C is all of this thing here. And I'm going to factorise this using the AC method, using these three things, using A as being 5, B as being minus y, and C as being minus 4y squared. Have a go and see, pause the video now and see if you can do it now, if you struggled with it without any help, and see if you can manage to do that. Okay, so here I'm going to do AC. 5 times minus 4y is minus 20y squared. So I'm looking for two numbers that multiply to minus 20y squared and add to give minus y. So let's start to think of kind of factors of 20. So like 5 and 4. Those are the ones that have a difference of 1. So it's something to do with 5 and 4. I want minus, so it's going to be minus 5 and plus 4. And I want minus y, not just minus 1. So I guess we're going to go for minus 5y and plus 4y. And sure enough, you can see that minus 5y times 4y gives me minus 20y squared. And when I add those two things up, I get that minus yx. So now I'm going to split the middle using those two things. 5x squared minus 5yx, don't forget that x as well, plus 4yx minus 4y squared. Now let's do two single brackets. I can take 5x out of the first ones and I get x minus y. And then for these two I can take 4y out of both of them, and again I get x minus y. So we've got 5x plus 4y in one of the brackets and x minus y in the other. Really tricky question, that one. Well done if you managed to do it.